Hey everyone, welcome back to the channel. Today we're diving into some of the most incredible civil engineering projects from around the world. Let's get started. You know, I'm all about building things, figuring out how stuff works, and pushing the limits of what's possible. And when you look at these colossal structures, these testaments to human ingenuity, it's hard not to feel a sense of absolute awe. We're talking about projects that literally reshaped the Earth, defied gravity, and connected nations in ways previously only dreamed of. These aren't just piles of concrete and steel. They are symphonies of physics, mathematics, and sheer human determination. So what makes a civil engineering project truly a marvel? Is it the scale, the complexity, the audacity of the vision? Well, I think it's all of that and more. It's about solving seemingly insurmountable problems, often in incredibly harsh environments, and creating something that stands for generations, serving millions, sometimes billions of people. Today, we're going on a virtual world tour to explore 5 such marvels. We'll unpack the science, the challenges, and the incredible stories behind them. I've spent a ton of time researching these, and honestly, the more I learned, the more my mind was blown. Get ready to have your perspective on what humans can achieve completely expanded. We're going to look at how engineers tamed mighty rivers, pierced through mountains, scraped the sky, and even bridged valleys so high they touched the clouds. Each of these projects has its own unique story of triumph over adversity, of brilliant minds coming together to turn the impossible into reality. So buckle up, because this is going to be an epic journey into the world of mega construction and mind-bending engineering. Trust me, you won't look at a bridge or a skyscraper the same way again. Alright, first up we're heading to Europe to check out the Channel Tunnel, or as many affectionately call it, the Chunnel. Now this isn't just any tunnel, it's one of the most ambitious engineering feats of the 20th century, a dream that spanned centuries before finally becoming a reality. Imagine this. For the longest time, Great Britain was, well, an island, separated from mainland Europe by the formidable English Channel. People talked about connecting them, Napoleon even had plans, but the sheer challenge of digging a 31-mile tunnel mostly underwater seemed almost mythical. It wasn't just about digging. It was about pressure, water ingress, aligning 2 ends perfectly from different countries. This project wasn't just ambitious, it was borderline audacious, a true testament to what we can do when we put our minds to it and collaborate on a grand scale. So, how did they pull off this modern marvel? Well, it involved not 1, but 11 massive tunnel boring machines, or TBMs. Some of them the size of football fields, chewing through chalk marl deep beneath the seabed. These weren't just dumb drills. They were sophisticated underground factories on tracks, excavating, removing spoil, and lining the tunnel with concrete segments simultaneously. They actually dug 3 tunnels, 2 main railway tunnels for high-speed trains, and a smaller service tunnel right in the middle for maintenance and emergency access. The precision required was mind-boggling. They had to meet in the middle, and they did, with only a few centimeters of error. Think about that. Digging from 2 different countries, under the sea, and meeting up almost perfectly. That's some next-level surveying and engineering. The impact of the Chunnel has been absolutely transformative. Suddenly you could hop on a train in London and be in Paris in just a couple of hours, no ferries or planes needed for that direct city-to-city link. It revolutionized trade, tourism, and the very relationship between the UK and continental Europe. More than just concrete and steel, it became a powerful symbol of connection, a physical link where there was once only water. It's a constant reminder that with enough brainpower, a whole lot of grit, and some seriously cool giant drills, we can overcome even the most daunting natural barriers. It's a project that continues to inspire engineers and dreamers alike, proving that even the wildest ideas can sometimes be tunneled into existence. Next, we're jetting off to Dubai to crane our necks at the undisputed king of skyscrapers, the Burj Khalifa. Standing at a staggering 828 meters, or over half a mile high, this thing isn't just tall, it's ridiculously, unbelievably tall. Building something that pierces the clouds presents a whole new universe of engineering challenges. You're not just fighting gravity, you're battling wind, extreme temperatures, and the sheer logistical nightmare of getting materials and people up that high. When they first proposed this, I bet a lot of engineers thought, you want to build high? It was a project that demanded innovation at every single step, from the foundation dug deep into the desert sand to the very tip of its spire. So what's the secret sauce that keeps this behemoth standing strong and not swaying like a noodle in the desert wind? A lot of it comes down to its ingenious design. The architects and engineers developed a buttressed core structural system. Imagine a strong central hexagonal core with 3 wings or buttresses supporting it. As the building rises, each wing sets back in a spiral pattern, which is not just for aesthetics, it critically confuses the wind. This shape disrupts wind vortices that would otherwise cause the building to vibrate dangerously. They conducted countless wind tunnel tests to perfect this, And then there's the concrete. They had to develop special mixes that could be pumped to unprecedented heights over 600 meters up. That's like pumping a very heavy milkshake up the Empire State Building twice. The foundation itself is a marvel, with 192 piles buried more than 50 meters deep into the ground. The sheer amount of materials used is mind-boggling. Hundreds of thousands of cubic meters of concrete and tens of thousands of tons of steel. But beyond the numbers, it's the human element. The thousands of workers from all over the world who toiled day and night in scorching heat to bring this vision to life. The Burj Khalifa isn't just a building, it's a statement. It's a testament to human ambition, pushing the boundaries of structural engineering and architectural design further than ever before. Every time I see it, I just think about the incredible problem solving that went into every single floor. Now let's shift gears from soaring heights to immense power and scale as we visit the Three Gorges Dam in China. This is, without a doubt, one of the largest and most powerful hydroelectric projects ever undertaken on Earth. Spanning the mighty Yangtze River, its primary goals were monumental: to control the devastating floods that historically plagued the region, to generate massive amounts of clean electricity, and to improve river navigation. The sheer scale of this undertaking is almost impossible to comprehend. We're talking about a concrete structure over 2 kilometers long and nearly 200 meters high, holding back an enormous reservoir that stretches for hundreds of kilometers. It's so massive, it actually had a measurable, albeit tiny effect on the Earth's rotation. From an engineering perspective, the Three Gorges Dam is a titan. Constructing a dam of this magnitude involved pouring unimaginable quantities of concrete, enough to build several Hoover dams. It features colossal spillways designed to safely discharge floodwaters, capable of handling flows that would overwhelm most other dams. One of the most fascinating engineering components is the ship lift, a sort of giant elevator for vessels, capable of lifting ships weighing thousands of tons up and down the height of the dam in a single go, allowing navigation to continue past this massive barrier. The power generation capacity is equally staggering, with dozens of massive turbines churning out electricity equivalent to many nuclear power plants, significantly contributing to China's energy needs and reducing reliance on fossil fuels. However, a project of this magnitude inevitably comes with significant impacts, and the Three Gorges Dam has certainly been a subject of much discussion. The creation of the vast reservoir meant the displacement of over 1 million people from their homes and communities, a massive social undertaking in itself. Environmentally, it has altered ecosystems, affected fish migration, and there are ongoing concerns about sediment buildup behind the dam and erosion downstream. These are complex issues with no easy answers, highlighting the profound responsibility that comes with engineering on such a planetary scale. It serves as a powerful example of humanity's ability to reshape the natural world, but also a reminder of the critical need to carefully consider all consequences, both intended and unintended. Our next stop takes us to Central America, to a legendary waterway that literally changed the course of global trade, the Panama Canal. For centuries, ships wanting to travel between the Atlantic and Pacific Oceans had to make the treacherous journey around the tip of South America Cape Horn, a voyage that could take weeks or even months. The dream of a shortcut, a canal slicing through the narrow Isthmus of Panama, was an old one, but the challenges were immense: dense jungle, mountainous terrain, tropical diseases, and incredibly complex geology. The French first attempted it in the late 19th century, but were ultimately defeated by these formidable obstacles, particularly malaria and yellow fever. When the United States took over the project in the early 20th century, it wasn't just an engineering challenge, it was a medical one too. Dr. William Gorgas's efforts to eradicate mosquito-borne diseases were as crucial as the engineering itself. The construction was a Herculean effort, involving the excavation of hundreds of millions of cubic yards of earth, most famously at the Culebra Cut, a deep trench carved through the Continental Divide. Perhaps the most ingenious part of the canal is its lock system. Because the canal rises and falls across the landscape, ships are lifted and lowered through a series of massive locks, using gravity-fed water from Gatun Lake, an artificial lake created as part of the canal system. This system was a world first in terms of scale and complexity at the time. The opening of the Panama Canal in 1914 was a monumental achievement, effectively shrinking the world for maritime trade. It cut thousands of miles and weeks off shipping routes, boosting economies and connecting distant markets. It's a project that holds numerous records for its time, from the sheer volume of excavation to the size of the lock gates. And it hasn't stood still. In 2016, a massive expansion project was completed, adding a new lane of traffic and larger locks to accommodate the new generation of massive Neo-Panamax ships. The Panama Canal remains a vital artery of global commerce and a stunning example of human perseverance and engineering brilliance overcoming incredible adversity. It truly is a pathway between seas built with sweat, ingenuity, and a whole lot of concrete. For our final marvel, we're heading back to Europe, specifically to southern France, to gaze upon a structure that seems to float effortlessly above the landscape, the Millau Viaduct. This isn't your average bridge, it's a cable-stayed masterpiece that spans the Tarn River Valley, and it's so tall that its highest pier is actually taller than the Eiffel Tower. When you see it, especially on a misty morning when the valley below is filled with clouds, the bridge deck appears to be sailing through the sky. It's an incredible blend of engineering prowess and breathtaking aesthetic beauty, designed to be as unobtrusive to the stunning natural scenery as possible, which is a challenge in itself for such a massive structure. The engineering behind the Millau Viaduct is truly elegant. It's a multi-span cable-stayed bridge, meaning the deck is supported by cables fanning out from 7 slender, tapering pylons. These pylons are incredibly tall, with the tallest reaching 343 meters from the ground to the top of the mast. One of the most fascinating aspects of its construction was how they built the deck. Instead of lifting individual sections, large prefabricated steel sections of the roadway were assembled on land, and then hydraulically pushed or launched out from both sides of the valley, inch by inch, across temporary piers until they met in the middle. This required incredible precision and careful calculation of stresses. The design also had to account for wind, thermal expansion, and even tiny movements of the earth. Now, for a fun fact, or rather a testament to its design philosophy, the Millau Viaduct was designed by English architect Lord Norman Foster and French structural engineer Dr. Michel Virlegu. They aimed for the elegance of a butterfly rather than the brute force of some older bridges, and they achieved it. It's so well integrated into the landscape that it almost looks like it belongs there. A delicate yet incredibly strong ribbon of steel and concrete. Driving across it is an experience in itself, feeling like you're suspended high above the world. It's a perfect example of how engineering can be both incredibly functional and profoundly beautiful. A structure that inspires awe not just for its size but for its grace. It really is engineering as art. And there you have it, 5 absolutely mind-blowing examples of civil engineering that have shaped our world. From the depths of the English Channel to the skies above Dubai and across vast rivers and valleys, these projects showcase the incredible power of human ingenuity, collaboration, and the relentless desire to solve big, hairy, audacious problems. It's one thing to see pictures, but I really tried to dig into the how and the why behind these structures, because that's where the real magic happens, in the problem solving and the sheer determination. I hope this journey gave you a new appreciation for the engineering marvels that often stand silently around us or that we travel through, over, or under every day. These structures are more than just concrete and steel. They are monuments to our ability to dream big, and then, through science, engineering, and a whole lot of hard work, make those dreams a reality. They connect us, protect us, power our cities, and allow us to explore and interact with our planet in ways our ancestors could only imagine. And the best part? The story of engineering is still being written. There are brilliant minds out there right now, probably sketching on napkins or running simulations, dreaming up the next generation of world-changing projects. What challenges will they tackle? What new heights, depths, or spans will they achieve? It's exciting to think about. Thanks for watching. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more amazing content. Let me know in the comments which engineering marvel fascinates you the most, or if there are any others you think we should cover in a future video. I love hearing your ideas. Until then, keep exploring, keep questioning, and keep building. See you next time.